Today we're discussing how to find slope. In this video, we'll just cover how to find slope from a graph and how to find slope using 2 points. Now, we talked a little bit about slope in class today, but the slope is the ratio of the change in y to the change in x. Anytime we say ratio, that's the same thing as a fraction. Slope is a value that shows the steepness too. So our slope should always just be a single number, and it'll tell us how steep our line is and what direction it's going, whether it's going up or down. So one way we find slope is we abbreviate slope, or we use the symbol letter M to define our slope. Slope is the rise over the run, which if we can think about these like stairs, rise are how high your stairs are or your steps are. Run is how deep or long your steps are. So rise is the change in y. And the run is the change in x. Now, a symbol that we use to represent change, and what you'll sometimes see for slope, is change. We use a little triangle symbol like this. We call it delta. So sometimes you'll see delta y over delta x. That just means the change in the y values over the change in the x values. We can also find slope using 2 points and using more of an equation. We'll get to this more later, so just write down the equation for right now. Slope is always given as y2 minus y1 over x2 minus x1. Let's calculate the slope from this graph using the rise and run part of the formula for slope. So remember that slope is the rise over the run. The rise is the change in our x values, and the run is the change in our y values. We always start reading left to right for this graph, so we're going to start with this point right here, which you have on your page as well, and then we'll move to this point on the right. Now, if I were to start here, let's first look at my rise, so how far I need to move up or down. I have to move up 1, 2, 3, 4 units to get to the new point. I have to move over, in this case, to the right, 1, 2, 3 units. So that's my rise. This is my run. My slope then is 4 over 3, which I can just leave as the fraction 4 over 3. I can find the slope in many different ways. One thing to note here is we have different kinds of slope. This slope ended up being a positive number. So, a couple things about positives and negative slopes then. Slopes can be positive or negative. We'll talk through 2 other options that we have for slope tomorrow. A positive slope is any way, if you're reading from the left to the right, that you would have an uphill slope. So left to the right, having it increase over time would be a positive slope. Now it could look really, really, really steep, like this line has a very positive slope. It could also look really gradual but still be positive. For example, this line, it barely looks like it's increasing, but it is. It's barely going uphill, so it has a positive slope. A negative slope, on the other hand, is any time that you're looking at a slope that's decreasing. My line's decreasing. We could also think that if I were reading left to right, I'd be walking down the hill, versus here, left to right, I was walking up the hill. That's a negative slope. I could have a really, really, really steep negative slope. I could also have a very, very gradual negative slope, which would look like that right there. My slope can either be positive, I'm walking uphill, negative, I'm walking downhill. Awesome. Let's just walk through a couple things that will help us find our rise and our run again. Just remember that your slope M is always the rise over the run. Now, to find the rise, you're always looking in that change in y. Now, remembering from our transformations unit, we can move something in the y direction up or down. If I move it up, it's going to be a positive number or a positive change. If I move down, it's a negative number. The run is always our change in x. And again, remembering from our transformations unit, moving right would mean I have a positive run. Moving left would mean I have a negative run. Now, making sure you keep track of those positives and negatives is very important. Otherwise, your type of slope will be incorrect. Let's do a couple more examples of finding a slope from a graph using our rise and run method again. So just remember that your slope m is always your rise over your run. Let's find our rise and our run in this case. I'm always going to read left to right, start with my left point. How much is my change in x? Well, I'm moving from this point to this point. I am moving up 2 units. So my rise here is a +2. My run, I would have to look at, okay, I'm right here. How far am I changing in the x direction? In this case, I'm going in the right 3 units. So my run here is also a +3. My rise over my run then is 2 over 3, which we are going to again use as 2/3. Now, I could also start from the right and read left. Just know that no matter where you choose your points, no matter where you start from, your slope will always be the same for this line. Let's prove it. If I start here and try to move to the point on the left, my rise would go, I'm going down 1, 2. Down 2 would tell me a -2. Then I'm moving to the left 1, 2, 3. That would tell me a run of -3. So my slope here then is -2 over -3. We always have to simplify, so our slope then simplifies to, well, a -2 divided by a -3 is still a +2/3. No matter the point you choose, you'll still get a +2/3. Let's try the next one in the same way. Now, I marked 2 points. We're going to start with those 2 points just to kind of work through our relationship here. I like to start left to right. Now, in this case, let's start with the rise. I need to go down 1, 2, 3, 4, 5, 6, 7. So I'm going down 7 units for my rise. -7 would mean that's my rise. I need to go to the right 1, 2, sorry, the wrong point, sorry. I need to go to the right 1, 2, 3, 4, 5, 6, 7. So that's a +7. My slope here then is rise over run again. That means it's -7 over 7, which is a slope that simplifies to -1. What the slope of -1 also means is that it also means that I'm going to keep going down over 1, down 1, over 1, down 1, and I have that slope all the way through. So if I chose a different set of points, I'd still have the same slope. Make sure you always are simplifying. One last check to make sure is I got my slope was negative here. My line, if I move left to right, is going downhill or decreasing, so it makes sense to have a negative slope. Here, my line is increasing, so it makes sense to have a positive slope instead. Let's try 2 more examples together. This time we're going to find the slope in between 2 points. Now, finding the slope using ordered pairs or points, we now need to use the formula instead. You don't have to put this on a graph and graph it because we have a formula. Our formula here is y2 minus y1 over x2 minus x1. All that's doing is talking about the change in the y over the change in the x. We can find the change by taking the difference of our 2 values. Now, let's just talk one thing. Where are these x and 1s and y 1s and x 2s and y 2 coming from? You can pick either of your points here to be point 1 and point 2. I'm just going to read left to right here. So I'm going to choose point 1 to be this point. That means that this value is x1 and this value is y1. This then has to be x2 and this has to be y2. If you chose to reverse them and have that be point 2 and that be point 1, you'll always end with the same slope. Just be careful that whatever you start with 0.1, that means that x value has to be x1 and the y value has to be y1. So if we were trying to find the slope from this line, then what we need to do is our slope is y2 minus y1. So in this case, that's negative 1 minus 4 all over x2 minus x1. That's negative 3 minus 3. Be super, super careful about adding and subtracting negative integers here. So negative 1 minus 4 gets me negative 5. Negative 3 minus 3 gets me negative 6. A negative divided by a negative is a positive, so I can simplify this slope to be 5 over 6. Please leave it as a fraction, and that's as simple as it gets. So our slope between these 2 points we found using our formula was 5 over 6. Now our slope between these points we can set up in the same way. I'm going to call this x1, y1. I'm going to call this x2, y2. I find my slope by taking y2 minus y1. That's negative 2 minus 1 over x2 minus x1. 1 minus negative 1. Now, negative 2 minus 1 is a negative 3. 1 minus negative 1 is a 2, positive. So our slope here is negative 3 over 2. Now, I'm going to really encourage you to leave your slope always as an improper fraction versus a mixed number. When we get to graphing, it's much easier to have our slope as an improper fraction than as a decimal or as a mixed number. So leave it like this. We now have our slope here is negative 3 over 2. We had a positive slope here and a negative slope here. Just be very careful that whatever you start with as 0.1, that has to end as 0.1. When you get to class tomorrow, I'll have you watch the second part of this video notes, and then when I get back to class on Friday, we'll do a bunch of practice problems together.